Hey, welcome back, students. This video we're going to do Module 4, Topic 4, Composition of Transformations. This is page 16 of the Module 4 packet. The standards for this, this topic, GR 2.5, that's given a geometric figure and a sequence of transformations. Draw the transformed figure on the coordinate plane. And then GR 2.3, that's identify a sequence of transformations that will map a given figure onto itself or onto another congruent figure or similar figure. The objective for this topic, you guys are going to determine the image of a figure after the completion of a composition of transformations on the coordinate plane and describe the composition of transformations that maps one figure onto another. So our warm-up for this topic, I'm going to ask you to pause right here. This goes back to topic 3, part 2. This is just another practice for that. We're rotating counterclockwise about point D. So I'm going to wait about 3 seconds to let you pause, try to work this problem, and then unpause, and we'll work it together. Okay, so for our warm-up, rotate the figure 90 degrees counterclockwise about point D. So the first thing we need to know is point D. So see, point D is at 1, -2. Pencil working here. So D, okay, let's try the red pen. Is 1, -2. All right, so we need our other points as well. So A is 1, -4. B is 4, -4. C is 4, -2. And of course we have D. Now, first thing, so if we're rotating about point D, that means as this guy moves, instead of rotating like from here to here and from here to here around the origin, we're using this point, it's not going to move. So if my thumb is point D, and this is the figure, if we rotate this way, my thumb doesn't move. If we rotate that way, my thumb doesn't move. So D is not going to move. So D and D prime are the same point. So D prime we can go ahead and fill in. That's 1, -2. So I'm going to use some different colors here because things might get a little dicey. So the first thing we need to do, so to rotate a point counterclockwise 90 degrees, it's going to be X, Y. It's going to be Y. Well, hold on. Let me just double check. When in doubt, I'm not in the classroom, so I can't look at our anchor chart. Give me just a moment. My little cheat sheet off my phone. All right. So -Y comma X. But first, because we're rotating from point D instead of from the origin, we're going to have to subtract out point D, do our coordinate rule, and then add it back in. So first things first, we're going to subtract point D. Point D is 1, -2. Now, of course, as we subtract, we're essentially taking the opposite sign. So 1 - 1, change pencils here. So 1 - 1 is 0. -4 minus -2, so your negative here makes this basically -4 plus 2. So we have -2. Excuse me. All right. Now, our coordinate rule. X, Y, -Y, X. So that's our X, that's our Y. So -Y, so if Y is -2, then negative y is, Lord, I'm sitting here saying this and writing, is positive 2. 0, the x just moves, but you can't change the sign with a 0 anyway. All right. So we changed our sign here. We're running out of room. Now we got to add back in point D. Again, that's 1, negative 2. So we're adding, so we're not taking the opposite sign. 2 plus 1 is 3. 0 plus negative 2 is negative 2. This is why I did this on the board in the classroom. So we're going to bring A over here. So we're 3, negative 2. And actually, that is the end. So, Lord, I should have saw that. So 3, negative 2. So let's go ahead and plot that. 3, negative 2. I don't think I plotted this in class. Okay. So, B, subtracting D. 1, negative 2. 4 minus 1 is, hold on, change out my flow here. 4 minus 1 is 3. Negative 4 minus negative 2. So same thing like this over here. That's going to be negative 2 again. So our x, y, negative y, so negative 2 becomes positive 2, just like it did over here. 3 comes around. Sorry, I dropped my pencil, my other pencil, so I'm down to blue. Meant to, so D, 1, negative 2. Sorry, I just got ahead of myself. So 2 plus 1 is 3. 3 plus negative 2 is 1. Okay. So 3, positive 1. Yeah. 3, negative 2, and 3, positive 1. Okay, check it. Of course, D stays the same. Now C. Use a regular pencil if it'll write. So first we're going to subtract D. 4 minus 1 is 3. Negative 2 minus positive 2. This is negative, negative. It's a 0. All right, you can't change the sign on 0, so 0 just comes forward. The x goes backward. Now we're going to add in point D again. That's 1, negative 2. 0 plus 1 is 1. 3 plus negative 2 is 1. Let me write it over here. Okay. Then 1, 1. So, as we rotated, because D stayed the same, we moved, even though I'm touching that, it moved here, and then, well, no, here, sorry. Just like it would have, as if we would have rotated 90 degrees about the origin, it would have ended up here like this. Same shape. We're here, we rotate, we go this way. We rotate, we go this way. We rotate, we go this way, and then finally when we get back, we end up where we started. Hope that made sense. All right, let's scoot up the page. So on page 16, position. All right, I got a little sloppy there at the end. Okay. So glide reflection and composition of isometries. When a transformation is applied to a figure, then another transformation is applied to its image. The result is called a composition. A glide reflection is one type of composition of transformations. A glide reflection is a composition of a translation followed by reflection in the line parallel to the translation vector. that's a lot of words. I'll show you. So, theorem 4.1, composition of isometries. The composition of two or more isometries is an isometry. So, the composition of two or more isometries, reflections, translations, or rotations, results in an image that is congruent to its preimage. So, all that is saying, basically, for now, when we move a figure, it doesn't matter if we rotate it, or if we reflect it, or if we translate it, or we do all those things. Where it starts and where it ends up, it's the same shape. This rectangle is the same. You see that there's 6 blocks inside, so the area is 6. It's still 6 over here. It's just turned to the side because it rotated. It doesn't matter how it moves. It's still going to be the same shape and the same size for right now. I say that because later we're going to dilate and then it changes. But for right now, all you need to know from this is that it doesn't matter if we reflect, we translate, or we do both, or 3 or 4 things. We're only going to do 2 max, by the way. But I'm saying it stays the same shape and size. Okay. So let's scoot down the page just a little. All right, bottom of page 16, number 1. Triangle PQR has vertices, and it gives us the coordinates for P, for Q, and for R. Determine the coordinates of the vertices of the image after a translation along vector -4, 1, and a reflection in the x-axis. Okay, so it keeps saying image. Remember back, pre-image is where we start, image is where we finish. So it's saying of the image because it's saying, here's where we're starting. I want the image after this and this. So the final image, I guess, is what it's saying, but instead of saying all the extra words. All right, first thing we're going to do, we're going to write these coordinates. So we have P, we have 1, 1, Q is 2, 5, and R is 4, 2. So I'm going to write this down here. Should have wrote it up there and did the problem below it, but we're here now. So the first thing we're going to do is translate it. The vector is -4, 0. So for that, your x comma y is going to be x minus 4 because our a is -4, and then it's going to be comma y because y plus 0 is just y. Okay? So we'll do that, and then see if this yellow will show up. So then from there, we're gonna reflect in the x-axis, and to reflect in the x-axis, x comma y, because this is where we're at now, becomes x comma -y. Make sure that's good, visible for you guys. Yep. Okay. Cool. Just making sure. Okay. So we're going to be working up here for this. So 1 minus 4 is -3. 1 just goes because it's just y. Okay. So now this is our x comma y. It's x comma -y. So your x stays the same. It was -3. It stays -3. Don't let its x make you want to change that. Don't. It's just x comma y is x comma -y. So x stays the same. All right. I noticed this in the work we did today, and then also just in some comments talking to some of you guys. Anyway, so now -y. So y is 1. -y is -1. So this is I should have wrote P prime, but that's our P prime. Okay, so we did all these steps. I'm just making sure you guys, I'm writing less here than I have on the board, but I want to make sure you guys are following. Those of you that are, watching. All right, Q. 2 minus 4 is -2. 5 is just 5 because it's just y. Okay. Now, so x stays the same. Negative y, so 5 becomes negative 5. If it was negative 5, we would change it. That means change it. It does. Yes, it's saying negative, but it's telling us that y is changing from y to negative y. Because, anyway, so this is our q prime. And then finally, r. Our 4 minus 4 is 0. 2 is just 2. Okay. Write r prime. I forgot the first two times. Okay. Negative x. So 0 is neither negative or positive, so we can't change it. 0 is 0 is 0. Negative y. So 2 changes to negative 2. So our r prime is 0, comma, negative 2. All right, number 2 is a you-do. Please pause the video here. This is almost exactly the same as this. The only difference, so the vector is 0, 4, 0, 4. This one's the x-axis. This is the y-axis. So work this problem. I'm going to wait 3 seconds, then unpause, and let's try to see how you did. All right, so number 2, triangle JKL has vertices. I'm just going to go ahead and write them as I talk. J is 6, negative 1. K is 10, negative 2. And L is 5, negative 3. Okay. So it's going to be x minus 4 and then y because it's 0. So x comma y goes here. And then our next step from there. So we're reflecting in the y-axis. So x comma y here is going to be negative x comma y. So notice the difference. Over here we did the x-axis and it was x comma negative y. Over here we did the y-axis, so it was negative x comma y. We have these anchor charts up, but as every chance I get, I want to tell you guys these things, so I'm hoping it'll slip in there. All right, so J. 6 minus 4 is 2. Negative 1 stays the same because it's just y. J prime. So negative x, so 2 was positive. Now it's negative x would make it negative 2. Y stays the same, so it's still negative 1. That's that one. 10 minus 4 is 6. Negative 2 is negative 2. This is k prime. Negative x, so 6 becomes negative 6, and then y is just y, so it's negative 2. And then lastly, L. 5 minus 4 is 1. Negative 3 is coming along for the ride. It's y is y. L prime, so negative x, so 1 becomes negative 1, and then y stays the same, so negative 3. So there's your L prime. All right, give me just a moment. Flip over here. Here's page 17. Okay, number 3. Triangle ABC has vertices and gives us the coordinates. Graph ABC and its image after a rotation of 170 degrees about the origin and translate along vector negative 2, 4. All right, I'm not going to graph this. This is graphed in the classroom. We did this together yesterday. So anyway, send me a message if you need the graph. But we're going to do the math part because that's what we need to. That's what we're about here on this video. So triangle. Let's see. So a rotation, 180 degrees. So that is x comma y becomes negative x comma negative y. And then the translation along vector negative 2, 4 So this would become your new x comma y. It's x minus 2, and then y plus 4. So down, to the left 2, and then up 4. So a is negative 6, negative 2. B is negative 5, negative 5. C is negative 2, negative 1. Yes, okay. All right, so the 180-degree rotation makes this negative x, so negative 6 becomes positive 6, negative 2 becomes positive 2. Negative 5 becomes positive 5, negative 5 becomes positive 5. Negative 2 becomes positive 2, negative 1 becomes positive 1. So we just change the signs on all those. All right, now this is our new x comma y. It's x minus 2, so 6 minus 2 is 4. 2 plus 4 is 6. This is your A prime. B prime will be, so 5 minus 4, 5 minus 2 is 3. 5 plus 4 is 9. 2 minus 2 is 0. 1 plus 4 is 5. There you go. All right, number 4, another you do. I'm going to wait 3 seconds. You know the drill. All right, number 4. Again, I'm not going to graph this, so we're just going to do the 2 points because it's a line segment. But the endpoints of CD are, I'm just going to go ahead and do this. C is negative 7, 1, and D is negative 3, 2. So I'm going to graph this line segment after a rotation 270 degrees clockwise, and then a reflection in the x-axis. So x comma y for your 270 degrees clockwise, that's the same as 90 degrees counterclockwise. Which is negative yx. And then your reflection in the x-axis, x comma y, is x comma negative y. So we're just going to do that. So negative 7, 1, your y is negative and comes up front. So 1 becomes negative 1 and negative 7 goes in the back. All right, then your x comma negative y. So negative 1 is still x. And so it just goes there. And then this is y. So negative y is positive 7. This is C prime. All right, D. So negative y, so the 2 becomes negative 2, and then x just stays the same. And then x stays the same, y changes signs. So D prime is negative 2, 3. All right, let's move it on down here. I'm going to try to sum this up to you rather quickly. Pretty simple, even though it's a little wordy. So, reflections over 2 lines. The composition of 2 reflections can result in the same image as a translation or rotation. Theorem 4.2, reflection in parallel lines. So, you see these lines are parallel. We're reflecting twice. So, to get to the other side, like the chicken crossing the road. The composition of 2 reflections in parallel lines can be described by a translation vector that is perpendicular to the 2 lines and twice the distance between the 2 lines. So all this is saying that the distance between here and here is 2 times this, and you'll see that on the next page. So down here, this is talking about reflections in intersecting lines. Notice these lines intersect, they make an angle. When we reflect like this little line over here, and then over here to cross the two lines, it's going to be 2 times the angle. So if this angle is, say, 50 degrees, then the distance between here and here would be 2 times that, 2 times 50, which would be 100. And that's what it says over here. About a point where the lines intersect and through an angle that is twice the measure of the acute or right angle formed by the line. So twice the measure of that angle. All right, page 18. So we have a few problems that are like that. It doesn't really say we do, you do, I do, so it's just me, so it's an I do. I'm going to do that with these 3. Using these rules at the bottom, I'm going to make it a little less wordy than I have in the past. So instead of making you write out, like number 5, so triangle ABC was reflected twice over line N and Q. What single transformation could map the pre-image, so where we started, onto the final image, where we ended up? It said that if they're parallel lines, and these are, then it's 2 times that. And that's theorem 4.2 that tells us that's going to be this times 2. Okay? So 3/8 times 2, that's 3/4 of an inch. And this is vertical, so it's a vertical translation, or yeah. Sure, that's what I'm saying here. Translation vector, or yeah, so vertical translation. Okay. Lord, I get a little lazy at the end there. Okay. Over here, number 6. Parallelogram ABCD was reflected twice over line N and Q. We started here, we ended up here. What single transformation could map the pre-image, that's here, onto the final image? Remember we said when the lines intersect, it makes an angle. And theorem 4.3 tells us that it's 2 times that angle, so 2 times 45, or 90. And that is a 90 degree, it's going this way, which is counterclockwise. Rotation. I kept wanting to call that a rotation. All right, number 7. Parallelogram ABCD was reflected twice over line M and N. What single transformation could map the pre-image, so we started here, onto the image? Notice, so parallel lines, we know that it's this times 2, that's theorem 4.2, so it's 4.2, and it's also 4.2 times 2, which is 8.4 meters, and this is a horizontal translation of 8.4 meters. And this one over here was a vertical translation of 3/4 of an inch. All right, let's scoot to the bottom. Number 8 and number 9 are it for this, and actually the end of this module. I'm going to just go ahead and do both of these. They're very similar. We're going to start with ABC. It says, are these triangles congruent? And they are. Just trust me. If so, what composition of transformations maps ABC onto DEF? So we're starting here and we're going here. And this just takes some practice. You can do the math, and I'll show you the math. But I'm going to show you by eyeballing this, okay? So we have A is going to be with D. B and E are corresponding, and C and F are corresponding. So notice A is over here to the left, D is over here to the right. So this thing is like, say, let me back out. So say this is like this, it's going to be like this down here. So it's completely upside down. So we can't reflect and move down. we could reflect and move over, but the simplest way is going to be to rotate, because if we rotate, we end up 180 degrees puts us, see, this is 2 away, draw it in yellow. See, B is 2 away, it's going to, and it's 1 here, so 1 here and 2 away puts us here. This is 2 from that, so 1, 2. This is 1, 2, 3, 4 from that, so 1, 2, 3, 4. So if we rotate 180 degrees, it's going to say, that puts us here. And then if we count, so again, this is A, this is B, this is C. So how far is A from D? It's 1, 2, 3. Didn't go up or down, but it went to the right 3. So it translated on vector 3, 0. So we had a rotation of 180 degrees, then translation 3, 0. Real quick, the math. A is at -4, +1. We're trying to get to D. D is at 1, 2, 3, 4, 5, 6, 7, -1. So let's put this down here, -4. Well, and I'm below where you can see me, so let me go down here. -4, 1, and we're trying to get to 7, -1. Okay, let's change colors. So if we're at -4, 1, the 180 degree rotation is -x, -y. So -4 becomes +4. Y, +1 becomes -1. 4 plus 3 is 7. -1 comes along. Look what we got here. That's how we got there. So that just proves what we did. So for number 9, I'm just going to show you the, well, actually I'll do the math because it's actually quicker for this. So R, of course, corresponds to R prime. Notice these are 2. This is in the middle. So this is 1, -4. 1, -4. R is over here at -8, +6. -8, +6. And I recommend doing more than 1 point, but for the video's sake and for the sake of time, I'm doing 1 point. So R is -8, 6. Nope, that's R prime. R is 1, -4, and we're going to this. So see, R's here. It's up pointed kind of that way. If we rotate it, it's going to go from here a little bit this way, so it's not going the right direction. If we go this, we rotate this way, it goes here and then here, so R is in the wrong spot. So this, if we reflect, this is 1 away here. It's going to be 1 away here. Let's see, hold on. Let's just put a, so x comma y, if we reflect in the x-axis, x -y. So our 1, -4 is going to be 1, +4. And then, so we have reflected in the x-axis, and then, so that would put us at 1, 4. Then we got to see how far R moves from here to get there. So it's 1 between here, and then this is 2, so that's 3, 5, 7, 9. So we went -9, -9, And then from here to here is just 1. So we translated -9, 1. So x comma y is going to be x minus 9, y plus 1. We can see that. Okay. So, so your 1, 4 up here. 1 minus 9 is -8. 4 plus 1 is 5. Well, I had that. It's actually, no, I think I'm wrong here. I think this, well, we're off by 1 digit. I'm not, no, it is 2. That's right, it is 2. We would have gone along this line. So yeah, it wasn't 1 up there, it's 2. My bad. So it would be y plus 2, and that makes it 6, and that gets us up there. Sorry. Okay. You guys have any questions, let me know in class. Till next time, have a good night.